This is lesson A3, the appendix lesson 3. We're going to talk about integration by parts today. And I know in our Calculus AB course you learned a few different methods of doing antiderivatives, the substitution method commonly used. But integration by parts is actually another method that's, I guess, commonly used, but used for products of algebraic and transcendental functions, such as x multiplied by e to the power x, or the products of two transcendental functions like e to the x times sine x. Okay? Now, if you're thinking about where this came from, well, let me show you how it appeared. Let's go back to derivatives. Yes, and if I asked you for the derivative of two things multiplied together, I hope you still remember how to sing the song. We have there a prime b, remember that? A and b, so a prime b. Oh, we use u and v, so I'll change the lyrics. It'll be u prime v plus v prime u, remember that? Product rule, that's right. So now what I'd like to do is I want to take the integral of everything. So I'm going to take the integral of everything. So the integral of d dx uv, and then of course to have the proper notation I need dx in the end. So that's the integral of u prime v dx, and then I guess I can separate that into two separate integrals, v prime u dx, right? Okay, and you're like, how does this help us out? Well, think about what happened on the left-hand side. The integral of a derivative. What do we get? Yeah, just uv. Okay, and then now to make things, I guess, a little bit nicer, I'm going to actually move one of these pieces. I'm going to move this piece here to the left side. So uv minus integration of, and I'm going to rewrite this as v times u prime dx. And that, of course, leaves us with just, and I'm going to write this again as u times v prime dx. Okay? And if you're thinking, oh, that's interesting, but what does that mean? Okay, I get it. Let's keep going. uv, well, that's pretty straightforward. Two things multiplied together, minus the integration of v. Now, this u prime dx, okay, think of u prime like, what, du dx times dx, right? So that just becomes du. So this will become v times du. And similarly, then, on the right-hand side, it becomes u, and the v prime dx will once again just be dv dx, so that'll be just dv. And you're like, why is this important? Well, it's important because now what I'm saying to you is, and I'm going to read from right to left this time, the integration of u times dv. So if you can split up a product into two parts, one part we call u, another part we call dv, well, that just equals to this lovely formula, u times v minus the integration of v du. Okay? And that is the formula for the integration by parts. That's right here. Okay? If you want a nice way of memorizing this, uv, I think of uv as ultraviolet, like light, right? Ultraviolet. And then v du, I think of it as voodoo. So ultraviolet voodoo is my way of helping you remember uv minus integration of v du. Okay? So you're like, okay, fine, there's a formula, so how do we actually use it? So here's the strategy here, okay? U is always the part whose derivative is pretty simple or simpler, okay? Or at least not more complicated than u itself. And then the dv is just what's remaining, usually the more complicated part. Okay? But also, that part should be easily integrated. Okay? And remember here, you only have two choices. So if one choice doesn't work, just try the other. Okay? So let me show you what I mean with these three examples. Whoops. I get it on the right page first. Okay, here we go. Example number 1. So, notice we have two things multiplied together. X times e to the x. Okay? So, one part has to be u, and that's something that's easy to differentiate. And the other part is dv, which is something easy to integrate. So in this case, they're both pretty easy to differentiate, but I think x is actually easier, to be honest, because it's a polynomial. So if I have u equal to x, that means the remainder, whatever is left over, is the dv part, so e to the x dx. So here's how I've split this up into two products. Okay? Now, when I said u equals x, I need to find du. And the derivative of x is just 1, but of course I should use the notation dx next to it as well. So x, this derivative is, you can say 1 dx or just dx. Okay? How about the integral then? So if the derivative is e to the x dx, what is the integral? So the integral, which would be v, I guess, right? The integral of dv is v. So the integral of e to the x is just, of course, e to the x. You're like, okay, now what? So now we have to use the formula. Remember the formula is ultraviolet voodoo, right? uv minus the integration of v du. So we're saying this integral is equal to u times v. So u is x, v is e to the x, minus the integral of v e to the x, and the du is our d to the x. So yes, we still have another integral, but by using this integration by parts method, we get a simpler integral to do. Because now the integral of e to the x dx, of course, is just, e to the x dx. Just joking. No dx, right? E to the x. And then what do we have at the end? This is an indefinite integral plus c. Okay? And you can always check these by taking the derivative and hopefully getting back what you started with. Okay? All right. Let me show you another example here. Here's number 2. X times sine 3x. Okay? Now once again, we have to let something equal to u, and then the remainder is dv. Once again, your two choices are pretty much x and then sine 3x. I'm going to make u equal to x, okay? And that means that dv is sine 3x, and don't forget that dx next to it. Du then, of course, if I take the derivative, is just 1 dx or just dx. And v, well, the antiderivative of sine is negative cosine. But don't forget this is 3x, so there's another factor we have to kind of remove, which is a 3, so I remove that by taking a 1/3 in front. Okay? And if you didn't remember how to do that, that's pretty much using the substitution rule. That would be the long way. Reverse chain rule, a much nicer way. Okay? So review that. Alright, so now we're ready. Once again, UV, ultraviolet, voodoo, minus V du. So U, V, negative 1/3, cosine 3x, minus integration of V, negative 1/3, cosine 3x, du, which is just dx. Okay, we'll continue to simplify this. This is negative 1/3 x, cosine 3x. The two negatives become a positive. I'm going to take out the 1/3, and I'm asking you now for the integral of cosine of 3x dx. Well, the integral of cosine is, of course, sine. Once again, the extra factor of 3 I have to take out, so let me just copy the first term, and then the antiderivative here is, I think, sine of 3x, but once again, another factor of 1/3, and then don't forget plus c. So if I wanted to write this, negative 1/3 x cosine of 3x plus 1/9 sine of 3x plus c. And there you go. You are done. Okay? Now, like I said, you might have thought, okay, maybe I'll make sine the u and then the dvx. Well, you can try that, and you're not going to be as successful. I know you're thinking it's kind of hard to figure out which one is which. Well, at the end of this video, I'll show you a little acronym you can use to also help you determine what the u function will be. Okay? Now, example number 3. arc sine x dx. And you're like, this ain't a product. Why do I even need this? Okay, let's hold on. Well, it's in this section, so we must be using integration by parts. So, okay, well, just hold on. Which part do I let equal to u? And which part do I let equal dv? Well, if you're thinking I only have one part, okay, that's arc sine. Do you even know the integral of arc sine? You're like, you don't. Neither do I. Well, not yet, at least. So how are we going to do this? Well, if I'm going to let u equal to something, it's something I can take the derivative of. And in this case, the only thing I can take the derivative of is, yeah, arc sine of x. So what's left over as my dv then? If you said dx, you are correct. So now, what is the derivative of arc sine of x? Well, that's just 1 over the square root of 1 minus x squared. Don't forget your dx. And then what is the integral of dx? Well, that's just going to be, yeah, x. Okay. uv minus integration v du. Here we go. U, arc sine of x times v, which is x, minus integration of v, which is x, times du, root 1 over x, 1 minus x squared dx. Okay, let me rewrite this nicer. I'm going to put the x here in front. X times arc sine of x, so we don't get confused. Going to combine this integral x over the square root of 1 minus x squared dx. And you're like, great, I have another integral. That looks pretty complicated. Yeah, but you can use another previous method to do this. You can use u substitution or reverse chain rule. I'm going to use u substitution to help us out, just so I can show you this as a review. Remember, u equals to 1 minus x squared, so du equals, or du dx equals to negative 2x. Or if I solve for x, I get du over negative 2x. Why is that helpful to me? Because now I can rewrite this as x over the square root of u, and dx is du over negative 2x. Look at that! Nice. The two negatives become a positive, so I have a positive 1/2. The integral, I'm going to change this root u in the denominator to be u to the negative 1/2 du. And then don't forget, I still have this whole thing here with x arc sine of x. And don't freak out. That part we've already done the integral of, so it's just the answer. Now we have to do the antiderivative of u to the negative 1/2, which becomes u to the positive 1/2 divided by 1/2, or multiplied by 2. And of course we still have our x arc sine of x. Notice the 1/2 and the 2's divide each other out, and then I'm thinking here we get x arc sine of x plus u, which is u to the half, and u, once again, we can resubstitute as 1 minus x squared to the 1/2, or if you prefer the square root, I'm okay with that as well. And then finally, don't forget, you got it, plus c. And there's your answer. Okay. Now, I did mention to you that there is kind of a mnemonic or a way to remember which functions you should choose to be equal to u. So let me just quickly show you that right now. One more thing I want you to remember. It's called limit. So this is the order you should be looking at when you're trying to determine u. So to determine u. L, of course, stands for, log functions. So if you have a log function, make that u right away. No questions asked, okay, because we don't really know the integral of log functions. The next one, I, stands for inverse trig. So like what we just had here with arc sine and arc tangent, arc cosine, if you see that, make that u, okay? And this is the order, so you think, okay, if there's logarithms, that's used first. If it's then no logarithms, look at inverse trig. Oh, then no inverse trig, the next thing you look at is p, which stands for the polynomials. Okay, and that's why in previous examples 1 and 2, the polynomial that I saw, x, was what I chose to be equal to u. Because after polynomials, then we have e, which is our exponentials, and finally t, which stands for our trig functions. Okay, this is the order that I commonly use to determine what u should be. All right, and with these tricks now, you should be able to try some of this out. All right, do that and then come back for part 2. See you then.